Yeah, hello to our course today. For those of you who have not seen me yet, my name is Carsten Tellmann and I work for GData. We are supporting this course since a few years now because we think it is really great educative stuff. And by supporting, I mean we offer an additional evening event. Every time we have an invited speaker here, this event will take place in the rooms of my company. Some of you I already saw last time, so I hope you enjoyed it and have told your colleagues here what it is about. Basically, we are offering a nice dinner and free drinks and a cozy atmosphere, so the idea is that you have the time to talk to our speaker today, to Freddy, or to people working in the antivirus industry field, especially if you want to talk to technical people and not the sales guys or something. All of you are welcome, and yeah, if you like to know more, the basic details you can see here, but if you like to know more about the whole event and what it is about, then don't hesitate to come to me after the talk. And yeah, now Freddy will introduce himself, so I will now go to my place without any further delays, and let's enjoy Freddy's talk.
So, welcome to my presentation, which is going to happen computers are hard. Despite the train strike, I made it. My presentation is about content delivery networks and how you can help them not cross-site scripting you. That means without you having to trust the admin of the content delivery network. We are doing that by using Subresource Integrity, which is a W3C standard, or yet to be a W3C standard. And it's something I've been working on for the last year or so. It allows us to verify that the script we are including from a different domain is actually the script we are expecting. It also works for style sheets, and to explain the whole thing, I will talk a bit about the web security model in general, content delivery networks, the security considerations for this specific standard, and then a feature roadmap for the specification of what we want to do in the future, and what we can do to help increase adoption for the standard. So, as Carsten said, something brief about myself. My name is Frederik. I used to sit in these rooms as well. I graduated a few years ago and studied IT security. I also started the HackPra, the hacker practicum, this event with Johannes 6 years ago. And nowadays I spend my time analyzing, reviewing, breaking, and securing software. For example, Firefox, Firefox OS, Thunderbird, our websites and services. And I also mentor newcomers who want to contribute to our open source. So if you have any questions about that, feel free to ask me later. Why I'm here. Mozilla as a non-profit organization is guided by 10 principles, which are called the Mozilla Manifesto. And principle number 4 basically says individuals' security and privacy on the internet are fundamental and must not be treated as optional. And that's something I'm trying to work on, making security on the web a bit better. So first of all, content delivery networks. Maybe show your hands. Who has seen code like this before? I hope everybody, yes. So you include a script or a style sheet on your web page, but what does it actually do? Well, for you as a website developer, it gives you a few neat things. First of all, by including it not from your own domain, but from a content delivery network, you get high performance. The endpoint is probably through DNS, Anycast, or something else. Geo-distributed, that means it's closer to your actual users. The requests are slimmer because there are no cookies associated with that domain in contrast to your own domain. And the main benefit is if everybody's using this exact same script tag, the script is already in the cache of all users visiting your website because other websites are using the same thing. And for some content delivery networks, you also gain metrics and analytics data about how many people try to reach this part on your behalf. To explain what this means from a security perspective, I'll talk a bit about the same origin policy. What an origin is basically the scheme, the host, and the port of a URI. And these three things are taken as a criterion to compare if a host name or if the scope of a web application matches something else. And another oddity that comes with it in the web is that you can execute scripts from any kind of domain, but you can't actually read them using JavaScript APIs or anything else because of the same origin policy, right? That means the same origin policy basically explains what the notion or what the scope of your website is. Everything that is in the same origin is accessible, and everything that is not in the same origin is not accessible. That also means if someone finds a vulnerability on one of your web pages, it can be used to access all of your web pages as long as it's on the same origin. That includes especially XML HTTP requests, which can be used to make subtle requests to anything on your origin. An attacker can look at the cookie. They can use DOM access by creating iframes to other pages, looking into forms, looking into password fields, making buttons do something else than what they're supposed to do. The attacker can, of course, look at the cookies, which are super interesting for login credentials. And the attacker can also use the permission associated with the origin, for example, geolocation, push notification, etc. And to emphasize how mean this can be, Christoph Kottowitz created this kind of script in 2010 called XSS track, assuming that you have a vulnerability on your about page, like whatever / about.html. He can actually use it to hijack your whole domain, and the most interesting thing would probably be the login page, which will be shown in an iframe, but because of the same origin policy, he can modify everything that is in the iframe and make the iframe as big as the whole page, so the attacked page will not be seen. And you think you're actually on the sign up or the login page, when in fact you're still on the attacked page. And you can make it even niftier by using the HTML5 history API, which allows you to overwrite what is in the address bar. So the user will not even notice that he's still on the about page, but he will think he's on the login page. And everything the user does is under the attacker's control. And that also means he can hijack the password, etc. And in essence, one vulnerability is enough. Just one attacker can help the attacker to persistently trap the user into his control. Because if you do something on the iframe, if you click a button or something, the iframe will change, but the outer window will not. And as long as you remain on the origin, the attacker has still full control over whatever the user is doing. So from a security perspective, a CDN is kind of risky. And why am I saying you that one vulnerability is enough? Well, because of things like that. Last year, jQuery was compromised, and according to this news blog post, actually twice. And to me, as a security engineer, using a content delivery network reads a bit like, dear burglar, here's the combination to our safe lock. Please don't wake us up. But the problem is not really too complicated from a theoretic perspective, right? We know exactly which file we want to include as JavaScript code, especially when we create the web page. We do not want to execute arbitrary JavaScript from this specific host name, for example, code.jquery.net. So what if there was something that would allow us to verify that the script is actually what we intended to include when we created the web page? Well, there is now, and it's called Subresource Integrity. This mechanism tells the browser to conditionally include something. So if the resource doesn't match what we intended to include, it just won't load. As I said earlier, this is a W3C working draft. The screenshot is wrong, actually. The latest revision is from yesterday, April 5th, which I've been working which I've been working on with a colleague of mine, Francois, and Devdata Arkavi from Dropbox, Joe Wienberger from Google, and also Mike West from Google, who's not an official editor of the standard anymore, but did a great deal of work on it as well. So how does it work? The script tag gets a bit longer, containing something I will highlight step by step. First of all, obviously, there is an integrity attribute, and that is what we would expect it to be, basically a digest of the resource we want to include. Let's recap, how do we achieve integrity with cryptographic hash functions? I'm pretty sure this isn't new to all of us, but just to remember, hash functions are very often used to check for accidental data corruption. In this common use case, you download a very, very big file, and then you can compute the hash over the file and compare the result with the one that is published along the file. So you can actually check, is this what I intended to download? Is this what the person who uploaded the file intended to tell me, to give me? And a few properties of cryptographic hash functions are that if we just change 1 byte or even 1 bit in the input, the output will change radically. And the output is always of the same length, wherein the input can be of variable length. And also it should be very, very hard to find 2 inputs with the same output, which is of course called a collision. That means we want to use a collision-resistant hash function. In our use case, that means normal jQuery, this digest, modified jQuery, a completely different digest. Of course, this whole mechanism will fail when a hash function is broken, but seriously, if a hash function is broken, a CDN doing stuff with our web page is probably the least of our problems. But doesn't that somehow reading cross-origin data? I mean, we can learn the hash of something that is on another origin, which is kind of like reading cross-origin data. So it should be somehow forbidden or disallowed. And we thought, well, maybe just learning the hash isn't too bad, right? Thankfully, we're working with a lot of smart people when we're doing the standard. And somebody convinced us that it's actually quite bad to just learn the hash of something that is on a different origin. So imagine some sort of JSON endpoint somewhere on the internet or the intranet, which gives you data like this: status authenticated, username Alice. An attacker can do something like this, which is basically compute the hash for Bob, compute the hash for Alice, compute the hash for whatever user I'm expecting on my web page. And I can check on the on-error or on-load events of all the script tags to actually see what has been returned. So I can brute force my way into knowing what the small JSON response returned, and I can find out which user is visiting my web page. And this is, of course, because all these requests contain cookies for the current session of the user. And this would be even worse with some sort of config file for a router or some other box in your intranet. This is especially worse because routers usually have default passwords. Most users do not change these default passwords. The defaults are widely known, and deploying security updates for these boxes is sometimes very, very hard. So one could use this to actually find out what the password is for the box and then use some additional attack like cross-site request forgery to actually modify something in the home router without actually having access to the home router, just because the user goes on an evil web page that is using Subresource Integrity. This is something we do not want, right? So we cannot really make Subresource Integrity work, like I said earlier, by basically learning hashes of resources on different origins. To fix this, we are using something called cross-origin resource sharing, which is also a more or less new specification. And this is a way to actually grant access to a host and saying, hey, this is really a public resource, you can learn everything about it. And it is basically opting out of the same origin policy protection. I can say, this is a public resource, everyone can include it using JavaScript or DOM APIs or whatever. And this is done by specifying a header, which is in this case called access control allow origin. In this case, it really only allows anonymous access. That means cookies are not really sent. And it's somehow like sending or executing curl on the command line. You really just get what everyone else would get, and not something that is associated with any kind of session or login. And that's actually what we achieved with the other attribute that I've shown before. We say, hey, make this an anonymous request that requires cross-origin resource sharing. I think in the future it will be implicit with the integrity attribute, but just for explaining things and in general, we would probably prefer clarity over conciseness. Of course, the details of sub-resource integrity are a bit more complicated, as always. So I'll go over a few corner cases that may be interesting to look at. First of all, what if the website contains multiple hash functions? In this case, the user agent, that is the browser, has to decide which hash function to take precedence over. In this case, it's very easy, right? We can see this one is a bit more secure than this one because it has a longer output length. But it may not be as easy if there are two hash functions of different hash function families with the same output length, right? Which one's more secure? I don't want to decide, really. That means the browser actually has to implement something that decides, when given two hash functions, which is more secure than the other. And we completely leave that to the browser and don't really touch it in the specification. Because we don't want to argue that this hash family function is more secure than this function. Though when it comes to bit size, the decision should be rather obvious. What if there are multiple hashes with the same strength but different values? Well, in this case, really just one of them has to actually match. And we can use that for resources where we expect them to update in the future. We know there's a new version coming along, but it's not yet hosted on the CDN. So we allow both the old and the new version, and we can make sure that the script loads in either case. It's also useful when we think about resources that change depending on whoever is accessing it. For example, because of browser sniffing, content negotiation, and other tricks that web developers are using. Another interesting case would be an outdated hash function. For now, obviously, we don't really include outdated hash function, right? We only include the new ones, the secure ones. But in the future, something might become insecure, and then we have to think, how do we deal with this? One idea would be to just like say, okay, we can't really check the integrity, so we'd rather not load it. But we cannot really break websites that are not maintained anymore, right? The web always has to be backwards compatible. That also means websites from 1995 still work, which may be a good thing. So we cannot really fail to load the file. All we can really do is complain to the developer somewhere in the developer tools or in some logging functionality and say, hey, we can't really verify that this is really matching the integrity. You may want to change your stuff. We're still making your website work for you, but it's probably not as secure as you would like it to be. Another question which we've been fighting very long on mailing lists, both in the standards committee as well as the browser implementers mailing lists, is whether this should be actually allowed over HTTP or just over HTTPS. I would argue, and this is more or less the decision we've made, that the main use case of this API is to protect yourself from a CDN that has been compromised. This would still work if you're over HTTP, right? You can still protect yourself from someone trying to mess up your web page by modifying something in the content delivery network. But of course, we cannot make any guarantees over the integrity of the HTML file, right? We cannot really say, this is the integrity, this is the HTML file the user wanted, this is the HTML file the server actually delivered, if we're not using HTTPS. So yeah, you can still protect yourself from an evil CDN over just HTTP using this technology. But if you want to provide the best security experience for your users, you should use encryption, which is HTTPS. There was another, right, somebody at some point suggested that we may allow using HTTPS, and then the sub-resource, the script, would be an HTTP, but because we verified the integrity, we could just like load the script and not say, hey, we blocked scripts because they're insecure, they are over HTTP on an HTTPS web page. Usually they are blocked in all browsers, and we want to keep it that way. I mean, with integrity, you would get the, okay, this really hasn't been modified, but you wouldn't get the, this is confidential, right? And this is what HTTPS is about as well. So in essence, you can use sub-resource integrity whenever and in whatever combination with HTTP and HTTPS, but I'd really recommend you deploying HTTPS for all the good cases of HTTPS. The next topic would be failover. What do you do if the script has been blocked? I mean, you can say, yes, an evil script was blocked, but the web page doesn't work anymore. That would be a bad idea, right? I mean, we want to protect the user, but we also don't want to stop them from using our website. And in certain cases, it might mean buying stuff from us or like somehow interacting with that, which means real money. So the website not loading would be really sucky. So we want to try to recover from failure. Using just normal JavaScript stuff, you can actually do it with something like this. You load the script with the integrity attribute and all the goodness of sub-resource integrity. And next up, you basically try if the thing that you wanted to include has actually made it into your DOM or into your JavaScript environment by testing whether window.jQuery is truthy And if it isn't, you do document write and then basically insert a script tag dynamically, which would load it from your own origin, which of course you should always consider trustworthy. That means that the website will continue to work. It may be slower because you're not using the CDN, but it will be safe. You can also do something else and like handle the error event on the script tag, like script whatever on error equals load other resource. But yeah, in general, you want to recover from failure, right? Next up, we want to talk about future work. What is there to be done to make sub-resource integrity even more interesting? This part is, of course, still in flux, and we want feedback and your opinion about these things to prioritize and understand what developer needs. For example, we could have some sort of built-in error recovery by specifying a fallback source. We could imagine doing this and then saying the same origin is considered secure because otherwise we wouldn't actually believe in the integrity part of it. But this here is, of course, a draft, and the actual syntax may be completely different. It's just something we could imagine. There's something similar which we've been thinking about, which is also not yet in the standard but may come in a future version, which would be some sort of integrity policy sent with a content security policy that could either mandate that all failed integrity should be blocked or just reported, or always a fallback should be attempted. And we could also say, hey, we want sub-resource integrity for everything. All sub-resources in this document require sub-resource integrity. And that brings us to what are the sub-resources, right? Again, this is not in the spec, this is just an idea. There are more use cases. As I said earlier, you can also use this for style attributes. And in the future, we really want to support all sub-resources, which include iframes, which have obviously a similar security property as scripts, but also images and videos. Why this is interesting for styles, I don't know if you've heard about this. There's been a presentation in the past and a very good paper, which I can recommend you to read, which is called Scriptless Attacks, Stealing the Pie Without Touching the Sill, from Mario Heidrich, who's also working at Ruhr-Universität. And it basically explains that you can do a lot of harmful things without actually cross-site scripting the user and just including style sheets. And then there's another problem for which I unfortunately don't have a slide for. If we imagine using sub-resource integrity for videos, the flow would be as following. You download a really, really, really large video, and then the video's on your disk. Then you compute the hash, and then it doesn't check out, and you wasted a lot of bandwidth on something that isn't really interesting to you or something you want to present to the user. To make this work, we're thinking about some sort of streaming hash function integrity way. Cryptographers know that there are Merkle trees and hash trees that you can use. But in standards work, you always want to rely on something that has been defined somewhere else, so you can write less stuff, and people can use something they've implemented for some other use case by just including something. But there is no real precedence for hash trees or Merkle trees, which also means we have to do all the thinking, which means we'll do it later. And arguably, the biggest attack surface is scripts and styles, which we can secure now using sub-resource integrity. If you're interested in Merkle trees and cryptography and streaming data, feel free to help us. This is an open process, and we do need your help. So the outline of what is yet to be done is completely open, and how to prioritize things is basically open to your feedback. Despite the official W3C working draft stuff, there is also an editor's draft, which is basically whatever I'm in the mood to push to GitHub and my colleagues as well. So you can engage on our mailing list, you can file bugs, you can also build tools or rant about stuff on Twitter, which some people also do, which I will then file bugs for. But yeah, this is really open to your feedback and your interaction. Feel free to join us doing whatever. And as I said, there is tool support needed, right? Humans are not very good at computing digests. Computers are very good at doing the hash function stuff, right? So we don't want to do it ourselves, and we don't want to do like command line, whatever, copy paste. And there are a lot of build tools to manage scripts, which front-end developers are using all over the place. For example, Gulp, Bower, Grunt, NPM, etc. And sub-resource integrity is not really supported in any of them. And help on this front would be really appreciated. This is also because I have, frankly, no clue about all these things. And another thing that is yet to be done is people have to enable CORS, right? Otherwise, sub-resource integrity will not be usable. So for any meaningful adoption of sub-resource integrity, we need content delivery networks to enable CORS. Fortunately, a lot of content delivery networks already do this. Unfortunately, the one I've been having in my slides does not. Yet, I actually started talking to the infrastructure and operations guy, and I'm really looking forward to talking to them, because I think there is no downside for them to sending this extra header, and there's a little, or actually a lot of benefit to actually do this. But if you host a content delivery network, or intend to host a content delivery network, or know someone who has a content delivery network, talk to them or let them talk to me. We need to enable CORS. Let's conclude. You can soon add integrity to secure your script loads. I mean, in theory, you can also do it now, but it will some time to take it to the release browser versions. It's already in the beta and etc. versions of popular browsers. But if you're interested in using it right now, you should, of course, follow the spec in case stuff changes. And then what I learned personally is that extending the web is not that trivial, right? Just learning a hash from something on a different origin, yeah, should work. Doesn't. So adding a simple feature like this takes a lot of time. It took us more than a year to get this all, like all the details ironed out, for example, different hash functions, etc. There is even more that makes it non-trivial that I'm happy to share afterwards. And then browser security needs to step up, and probably will step up. I mean, considering that the web is becoming more and more pervasive, more and more feature-rich, we have to improve the current security story, and the browser can help making it more secure with these open standards. And with that, I want to thank you for listening. Thanks to Markus for inviting me. Thanks to all of those colleagues who gave me feedback creating this talk, Simon, Tim, and Peppo, and whoever. That's it. Thank you.